So this is your Algebra 2 6.3 video, and this is all about graphing absolute value graphs. So take a look at number 1. It says use your graphing calculator to graph y equals 2x minus 4 on the standard window. So keep in mind, 2x minus 4, I mean, we know what that's going to be the graph of, right? Isn't that just a line with a y-intercept of -4 and a slope of 2? So when we graph that, not that we need the calculator to graph it, but when we graph it, it looks something like this. Okay, so number 2 says, leave the original line and now graph the absolute value of 2x minus 4. So I'm going to leave that there. Down here, I'm going to graph the absolute value of 2x minus 4. Let's see, I need to scooch this over. My thing's in the way. Absolute value of 2x minus 4. And this time, now the first graph was that line. It's in blue. So it's still going to be there. But this time I'm going to graph the absolute value graph in red, and I want you to see if you can tell the difference. Okay, so notice what happened with the absolute value graph. Part of it was the same, but then the part that was below is kind of flipped up. Can you see the cursor? I'm saying this part that was here on the original one is now kind of flipped up. So what's the difference in the two graphs? Well, we just said one of them was flipped up, but think about the concept of absolute value. So let me go ahead and put the absolute value graph. Remember, the absolute value graph was something like this. Wait a minute. 1, 2, 3, 4. Okay, so it was something like this. Absolute value graph did this kind of thing. Not perfect, but it was something like that, right? Kind of a V. And so does it make sense that where the original was just a line, but then when you put absolute value on it, it became positive? Well, when you had the line, right, that came all the way down, remember absolute value can't be negative. Well, isn't this part of the graph right here negative? In other words, it's below the x-axis, so it's negative. So whenever I put the absolute value on, it took this part that was negative and it made it become positive. Okay, but what I want you to kind of gain from this is, in general, when we're going to graph something with an absolute value, we're going to think about making what used to be negative become positive. So if I have the graph of the line y equals -3x minus 1, so I know it's got a y-intercept of -1, and I know it has a slope of -3, so down 3 over 1. Right, I could go this direction if I wanted to. So if I were just drawing the line, it would go through these points, right? Something like this, if I were just drawing the line. Well, if I take the absolute value of that, the part that was already positive, meaning the part that was already above the x-axis, right? So this part over here is going to stay where it is, right? It was already positive, but this part that was negative, meaning down below the x-axis, is going to just flip up and become positive. So instead of going through right here at -1, it's going to go through up here at +1, and it'll be something like this. Okay, so that's the absolute value graph. So if I have any particular line and I want to take the absolute value, I just take the part that was below and flip it up. Okay, so that's kind of a general concept, but here's where we're going to settle for most of today. The basic absolute value equation, we know the basic absolute value equation is y equals absolute value of x. Okay, so that's the basic, where there's nothing else going on. This is called the parent function. Parent function. Meaning there's a lot of different absolute value equations. This is the basic one. No numbers involved, so it's called the parent function. Okay, what do we know about this parent function? Well, because it's an absolute value, we know the graph is going to look like a V. In fact, the positive side of the V is right over here. It's got a slope of 1. It kind of goes right out through the middle. And then the other side of the V over here still has a slope of 1. Well, I guess it's really a slope of -1. Goes right out through the middle. But basically, this is the overall graph of the absolute value graph. So notice we said that the slope is 1, but I'm going to do this. I'm going to kind of put it in quotes Because yeah, it's positive 1 on this side, but isn't it really negative 1 on this side? The slope is negative 1. So we're just going to say overall it's a slope of 1, even though we know one side's positive, one side's negative, because that's how it's going to form a v. The domain, well, remember, domain is what are all possible x values. Doesn't this go from forever on the left side to forever on the right side? And what that means is you can put anything you want to in for x. It doesn't matter if x is positive or negative or 0. You can put anything you want to in for x. So for the domain, we're going to say all real numbers. For the range, well, remember the range are the possible y values. Well, notice this graph. Isn't it always from 0 on up? So for the y values, we're going to say the y is always greater than or equal to 0, which makes sense because the y is an absolute value. And don't you know that whenever you take the absolute value, your answer is always positive? Okay? So think back to the parabolas. Remember the vertex form of a parabola, right? Like this would be a vertex form of a parabola. So in this equation, what does the 2 on the inside of the parenthesis do to the graph? Well, do you remember what we said? Didn't that 2 shift the graph? How did it shift? It would shift it 2 units where? Remember how we said it's the opposite of what you'd think? So this would shift it to the left. And what does the 3 do? We said it's going to shift the parabola 3 units up. Remember the plus means it shifts up. What does the 4 do? Well, remember the 4 out there at the beginning, it was we kind of put it as the idea of slope, right? Because it determined how wide or narrow the graph was. Remember we said if it was a high number, it was kind of narrow. We said if it was a fraction, if it was low, it was kind of wide. Well, the same thing is true for the absolute value graph. We're going to apply the same concept to the absolute value that we did to the parabola. So for example, if I know I have an absolute value graph, so I know it's that V-shaped graph, but then that -2 at the end is just going to move that V down 2. So instead of having my V right here, if I were just drawing the basic V, if I move it down 2, that means it's going to be right here. So let's see. I'm going to keep my line straight because this is a nice straight V. Notice how I'm keeping the slope of 1 all the way through. So basically I just moved my V down 2. Look at number 2. What if the -2 is on the inside? Well, remember on the parabola, if it was on the inside, that was where you would shift it left or right. So the minus on the inside is actually going to shift it to the right 2. So now my V is over on this side. It was shifted to the right 2. It's still that same V shape. Now you might be saying, oh, it doesn't look like a V because one side is taller. Well, I just made it go to the end of the graph. I mean, if I were to extend it, it would keep going, right? Okay, take a look at number 3. On this one, the +3 is on the inside, so I'm going to shift it to the left 3, but then the -1 on the outside means I'm going to shift it down 1. So left 3, down 1. So that means that the vertex, left 3, down 1, is right here. And that's where I will draw my V from. Try and keep the sides nice and straight with a slope of 1. So nice and straight with a slope of 1. I just ran out of graph. Still the shape of a V. Okay, look at number 4. What is the negative out in front? Well, what did a negative out in front of a parabola do? Didn't it make it flip across the x-axis so it was opening down? Same thing is true for my V. It's just going to flip across the x-axis and open down. I hope what you're seeing is we're basically applying all the same things we did to the parabola to this absolute value graph. Okay, so on this one, I'm going to move it to the left 1 and up 3. Left 1 and up 3. And then that negative out in front is going to mean it's going to open down. So keep the kind of that slope idea of 1 nice and straight with a slope of 1, but it's just a V shape. Okay, number 6, I'm going to move it to the right 3 and down 2. So there's my vertex. And since the negative out in front means it's going to open down, so just keep your nice, neat slope of 1 extended as far as you have space. Okay, so let's play around a little bit with those numbers in front. Okay, so I know this is the basic parent function right here at the origin. I know it opens up, but remember how we said on the parabola, that's kind of like your slope. Well, the good thing about the absolute value, that is the slope, and I can mark it off as far as I want. Remember on the parabola, I said, hey, you can only mark that off 1 unit away from the vertex. But that's because the parabola wasn't linear. The absolute value graph is linear. It has lines in it. So I could just mark off a slope of 2 in both directions. Slope of 2, when I say 2, that means 2 or negative 2. And then I could draw my v. So the number in front basically changes the slope of those lines, both sides. So this one, not only is it moved 2 units to the right because of the -2 on the inside, but then out in front, I know my slope is 3. Negative means it's going down. So down 3 over 1, down 3 over 1, and I could draw that v. So the same thing is true, that the higher the number, the skinnier or the more narrow your v is. And if it's a fraction, like on number 9, it's going to be a bit wider. So let's see. I'm going to move it 1 unit to the left and 3 down. So 1 left, 3 down. There's my vertex. And now if I mark off a slope of 1/2, so up 1 over 2. And again, on these, because they're linear, I can do it like a normal slope, up 1 over 2. So on these, you can really tell that they're wider when they have that fraction slope. So there's the one side of the v, and there's the other side of the v. Okay, so there it is. Today is about learning that the absolute value graph is a v, but then applying all those same transformations that you learned on parabolas.